Here in the campus, we do have automation, but a lot of our production data was collected manually and the process was lagging and inefficient. This resulted in unnecessary production losses and inefficiencies. Based on these challenges, we started with operational assessment to identify any shortcomings on the production line. We partnered with the production engineers and line operators to find out what the problem is and to meet their needs. We added a part count jig at the Z18 solder station to count the parts in real time as they are being produced. We added this inductive sensor and a SIG 200 to monitor the data on the line, process it, and then send it up to field analytics to visualize it. On the second screen, we implement the end-of-line tester data. This is the historical and live data, and this enables the production team to identify any imbalances between the start of the line and the end of the line, and lets them react quicker to it to make sure we balance the line and get better optimization on the line. The field analytics dashboard is easily accessible via our network, and this is available for production and also for management. We see many factories like this in the market where they've added manual data collection, and they keep on adding manual data collection, and this is a great opportunity for field analytics to be added.
Our digital technical consulting team has identified another Industry 4.0 opportunity here at the compressed air machinery room. Compressed air is a commodity in many industries. This commodity comes with a very hefty price tag when compared with other sources of energy. The energy monitoring solution we have deployed here can help you monitor this energy usage and is critical to produce sustainability and save costs. With this solution, we can identify times when certain systems can be turned off or set to standby mode. We can also identify energy, compressed air consumption peaks, allowing us to stagger machine startups and avoid these peaks. Additionally, the data transparency enables data analysis, which can identify leakage and overconsumption, detect deviations and changes, which could be an indication of leakage or wear, and enable you to calculate compressed air cost allocations per production cell. Based on these principles, we've installed our FTMG gas flow meters on the supply side of our compressed air system. This allows us to confidently know what we are generating, verify that our system is operating as designed, and flag leakage. Our next step is to add these same flow meters to the production cells behind you. This will enable us to drill down to each production cell and identify usage, narrow down leak detection, and enable us to calculate compressed air cost allocated to each individual production cell. Additionally, we've installed 2 multi-physics boxes which are monitoring the condition of the motors of the compressors. You can learn more about our condition monitoring solution near the conveyors behind you on the left. All 4 of these sensors are connected to our SIG 200 IO-Link master and are providing data to our field analytics platform, so the operators in the plant can see and manage their resources to maximize productivity while minimizing energy use. The field analytics dashboard displayed here are demonstrating a combination of live data, historical trend data, and data that has been transformed into enriched information in the form of cost data. Using the field analytics platform, the digital technical consulting team was able to create these customized user interfaces in 8 hours, which is very fast to engineer solutions specific to this application and this factory.
A few minutes ago, over on the other side of the facility, you just witnessed on the compressed air application on the Z18 and the H18 line how our DTC team provides consulting services and Industry 4.0. We implemented these solutions to meet the production and customers' needs. Daniel has demonstrated how he was able to digitalize and transform the manual process from capturing the counts and digitalizing that into a digital format. And William had walked you through how he was able to improve efficiency and give us the readings for the compressed air application. So here we demonstrate our digital solutions, and we continue to monitor and upgrade the system to show more the process and the solutions in our factory. Here's another application where we apply our condition monitoring solution using our sensor, the multi-physics box, connected to our SIM device, sensor integrated machine, and then tied into our field analytics. So we leverage the sensor and the intelligence of the sensor to capture the data, we harness it through the gateway, and we display it through these dashboards. With the digital solution offerings, we can deliver a proactive, reliable, and smart maintenance program. It does predict and reduce machines' failure, helps with the maintenance costs, thus increase productivity. This will extend the equipment lifetime, and it's an example of providing more data beyond what is typically provided through the existing legacy machines and automation systems. We do see a huge potential for incremental upgrades for our customers and existing automation. With customers embarking on digital transformation journey and Industry 4.0, we are observing a greater demand to get a better insight onto the operations and the facilities. This raw data is then associated with contextual data that can be converted onto actionable data. We do deliver these solutions using our SIG components, like we mentioned earlier, the hardware, the software, and the services part, leveraging our field analytics software coupled with the integration services. It does offer an easy to implement and easy to use scalable solution. With that, we're able to help companies simplify the complex IIoT deployments while providing critical visibility and monitoring and managing their IT and OT operations. We do this to accelerate their digital journey, improve factory uptime and productivity and quality.